Okay, welcome to part 2 of today's video. Just a quick little reminder, when a equals 1, you ask yourself what numbers add to get b and multiply to get c. So if we look at what we have here, we have x squared plus 7x plus 12. b is 7, c is 12. Remember, ax squared plus bx plus c. So here we're going to what's going to add to equals 7 and multiply to equals 12. And if you think about that, it ends up being 3 and 4. So 3 plus 4 equals 7. 3 times 4 equals 12. So whenever we do this as well, whenever we're factoring trinomials, it's going to factor into two binomials. The first term is going to be x and x, because x times x is going to be our x squared. And then if it's positive, you put a plus. If it's minus, you put a negative. So since both these are positive, it's going to be positive 3 and positive 4. It doesn't matter which one comes first, as long as x plus 3 is in one of them and x plus 4 is in the other one. Now let's check this and just make sure it works. So we're going to do a quick little check. X plus 3 times x plus 4. Distributive property, we get x squared plus 4x plus 3x plus 12. Those middle terms, so we get x squared plus 7x plus 12, which is what we started with. This is called standard form, and this is the factored form. So it depends on what you're looking. And as we go through the next couple of units, we will be going back and forth between standard form and factored form, and going back and forth and doing different things, manipulating, putting things together, refactoring it, remultiplying it out, just all sorts of different stuff as we go through. Okay, let's do some practice examples based on these two things that we just talked about. So let's start out with example 3. So with example 3, let's do 12x cubed minus 18x. So it's not a trinomial. We always need to look for a GCF first. So let's see if there's a GCF. We have 12 and 18. The largest number that goes into both is going to be 6. We have x cubed and x, so they both have an x. So we look for the smallest exponent that goes on that variable that they all have. So it's going to be x, so 6x is going to be our GCF. So now we're going to divide it out. So we're going to divide by 6x, divide 8x by 6x. 6x is going to go in front of our parentheses. 6 goes into 12 twice. X cubed divided by x. Remember, when you divide like bases, you subtract your exponents. So that becomes x squared. 3 minus 1 is 2. Minus 6 goes into 18 or negative 18, negative 3 times. And x over x just becomes 1. And so this is going to be our factored answer. Multiply it back out just to check. 6x times 2x squared is 18x cubed. I'm sorry, not 18. 6 times 2 is 12. There we go. And then minus 6x times 3 is 18x. And that's what we started with, so we got it right. Okay, so now let's do another one of these. And if ever you need to go back to check something, please do. Example 4, let's do 9x plus 14y. Okay, so for this one, what goes into 9 and also into 14? Only 1, right? That's 3 times 3 and 9 times 1. And that's 1 times 14 and 7 times 2. So they don't have any common factors. They don't share a common variable. So this one can't be factored. And if it can't be factored, another word for that is prime. It's only divisible by 1 and itself. We'll talk more about that as we go through things. Okay, let's do example 5. For example 5, let's do x squared minus 8x plus 12. You'd go ahead and pause this and do that one on your own, and then let's start it back up. Okay, welcome back. So remember, you ask yourself, what's going to add to equal negative 8? What's going to multiply to equal positive 12? Remember, if they have to multiply to get a positive number, that means that either both of them are negative or both of them are positive. And so if they're adding to get a negative number, that means they're both going to be negative. What numbers are going to multiply to get 12 and add to get negative 8? That's going to be negative 6 plus negative 2 and negative 6 times negative 2. So when we fill in our binomials, one is going to be minus 6, the other is going to be minus 2. Now if you take the time and check that, which I hope you do, you will find out that it does work. Okay, we have 2 more examples to do. We're on example 6. I'll put that one right here. Why not? Where are we? There we are. So for example 6, let's do x squared plus 2x minus 15. So let's go ahead and pause this one now, and then we'll keep talking about it when you come back. Okay, so you ask yourself, what 2 numbers are going to add to get positive 2, the b value, and they're going to multiply to equal negative 15, which is the c value. If we think about it, it's going to be 5 times negative 3. 5 plus negative 3 is going to get us the positive 2. Remember, it has to be a positive 2. 5 times negative 3 is going to get us the negative 15. So this is going to be x plus 5 times x minus 3. If you check it, it will work. Remember, it doesn't matter if you do x minus 3 and then x plus 5, as long as the x plus 5 is in one of the parentheses and x minus 3 is in the other parenthesis. Okay, we have one more example to do, and then we're done for the day. Example 7. Let's do x squared plus 3x plus 7. So let's go ahead and pause this, and once you're done, start it back up. Okay, so here they're going to add to equal 3. They're going to multiply to equal 7. There are no numbers that multiply to get positive 7 and add to get positive 3. So this one is not factorable. And if it's not factorable, just like on example 4, this is also called prime because it's only divisible by 1 and itself. Please let me know if you have any questions, and I hope you have a good evening.